we are now going to talk about subtracting fractions with borrowing. In the first example, we will have 5 minus 111. Remember, whenever any problem for addition or subtraction is presented horizontally, rewrite the problem vertically. This way you can work with it. Now, let's talk about this whole number 5. Remember, this whole number 5 is actually 5 groups of 11. One, two, three, four, 5. Those 5 groups of 11 out of 11 make up the whole number 5. Now, I can't take nothing minus 111, so I need to come to the 5 I now need to borrow. I'm going to borrow 1. Now, the 1 that I'm going to bring over here is one of these groups, and this is what you're going to think mentally. So that 1 I'm going to borrow is going to be an 11 out of 11. 4 and 11 out of 11 are equivalent to 5. I can now subtract 11 11 minus 1 11 gives me 10 11. 4 minus nothing is 4. I cannot reduce, so I have a final answer. Now let's go to a little bit harder problem. 6 and 12 over 32 minus 1 and 3/4. We have already discussed how to find LCD and the two methods that you can choose from. Maybe you can recognize that all I need to do is change the denominator of 4 into an equivalent fraction that has a denominator of 32, and that is the only one I need to work with. So I'm going to multiply this times a fractional 1 of 8 over 8 to create an equivalent fraction that has a denominator of 32. And I know that my fractional 1 will be 8 over 8 because 4 times 8 equals 32, and 32 is my LCD. 3 times 8 will give me 24. Now I have 12 over 32 minus 24 over 32, and I have a problem because I can't take 12 minus 24. So I need to come to the 6, and I need to borrow and take out a 1. Now the 1 that I'm going to bring over here is cut up into 32 pieces. So that 1 is equivalent to 32 over 32. And I'm going to add that 1 on to what I already have, and I'm going to end up with 44 over 32. I combine 12 over 32 plus the 1, 32 over 32, and I have 44 over 32. Now I can subtract. I will only work with numerators. 44 minus 24 is 20. Do not forget the whole numbers. 5 minus 1 is 4. Always reduce the answer to simplest form. I'm going to think in my head, I can divide 4 into 20 and 4 into 32, which will give me 4 and 5/8. Final answer. Now I'm going to do one last problem that is a more complicated problem for you, and I'm going to demonstrate the Venn diagram to find LCD. We have 17 and 4/9 minus 16 and 15/16. You can use option 1 of listing out multiples, or you can use the Venn diagram. I'm going to do the Venn diagram on this one, so I'm going to build my Venn diagram. I will label this circle 9 and this one 16. I'm going to build a factor tree for 9. Factors are 3 times 3, and they are both prime. I'm going to build a factor tree for 16, and I'm going to use 2 times 8. 2 is prime. I will factor out 8 as 2 times 4, and I have another prime. I will factor 4 as 2 times 2, and finally I have all prime factors. Now I always look to see if I have anything in common that goes in the overlapping area of a Venn diagram. And there are no common prime factors. So I'm simply going to fill in the Venn with what I know. For 9, I have the 2 primes of 3 times 3. For 16, I have 2 times 2 times 2 times 2. Now, always double check your Venn. In the first circle, 3 times 3, does it equal 9? Yes, it's good. In the second circle, 2 times 2 is 4, times 2 is 8, times 2 is 16. It matches, so I know that my data in the Venn is correct. Now here's where I told you we're looking at LCM, and I'm going to take the long way home. I'm going to think LCM, L, long way home. And I'm going to have to multiply. And I'll go as far as I can independently. After that, use your calculator. 3 times 3 gives me 9. 9 times 2 is 18. 18 times 2 is 36. Now from here I would assume you might want your calculator. 36 times 2 is 72, and 72 times 2 is 144. That LCM that we discovered on the Venn is our LCD. We've got a big LCD to work with. So I'm going to bring that back up here into the fraction, and I'm going to set up the format that we have talked about, multiplying both of these by a fractional representation of 1 to change both of these to an equivalent fraction that has a denominator of 144, which is our LCD that we found. Now use what you know to find what you don't know. I can't tell you off the top of my head 9 times what equals 144, but I can work this backward and I can say 144 divided by 9 will equal this factor, and it is 16 over 16. I must use the same process here. 144 divided by 16 is going to give me 9, so this fractional 1 is a 9 over 9. Use your calculator. Use the tools that you have. Now I'm going to multiply here and get my new numerator. 4 times 16 is 64. 15 times 9 is 135. Now I'm subtracting, and I cannot take 64 minus 135, so I'm going to need to borrow here. This will become 16, and the 1 that I'm going to bring over here is cut up into 144 over 144. That is equivalent to 1 in our common denominator. Now I'm going to combine those. I am adding those, and you must demonstrate this process that is being added on. 64 plus 144 is 208 over 144. Now I can subtract. I can take 208 minus 135, which is all over 144, and I get an answer of 73 over 144. Here's where you need to apply divisibility rules. This cannot be reduced, so we would term this as relatively prime, one of the vocab terms that we have been talking about, and then we have our final answer. Again, an example of the Venn diagram to find LCD. When you borrow, demonstrate the 1 that you're bringing over and that you're adding it on, then creating equal a total amount that you have. Over here, do not forget the whole number. 16 minus 16 was nothing, so I didn't have anything to work with. We sometimes get so busy in the work of the problem that we will forget whole numbers, so just a reminder to check that. Play the video as many times as you want. Move it ahead, move it backward. good luck, and I will see you again.